Since the 1950s, humanity has produced an alarming 9 billion tons of plastic, with a staggering 165 million tons finding its way into our oceans. Annually, almost 300 million tons of plastic waste accumulates, which is equivalent to the weight of the entire human population. Only a mere 9% of plastic undergoes recycling, which leaves a daunting 91% to either pollute the environment or occupy landfills. Traditional plastic, which is derived from petroleum-based materials, poses a significant challenge. These plastics are non-degradable, which adds to the increasing waste problem, especially in the form of packaging materials. In response to this crisis, I introduced ChitoPlast, an innovative bioplastic derived from mushrooms. Bioplastics, which comprise only 1% of the global plastic production, face underutilization due to inefficiency and high costs. ChitoPlast disrupts the status quo by offering a solution that is both economically viable and environmentally sustainable. To comprehend ChitoPlast's revolutionary approach, one must understand the science of chitin-based bioplastics. Chitin, a long-chain polymer abundantly found in nature, serves as a foundational material for ChitoPlast. With an estimated annual production of 1 billion tons globally, chitin becomes the primary component in a simple bioplastic recipe, which includes converting the chitin into chitosan and mixing it with vinegar. In our ChitoPlast, mushrooms play a pivotal role because they contain high percentages of chitin, typically within the 8 to 43% range. To optimize these levels, our ChitoPlast starts with lab-grown mushrooms, strategically modified to contain over 50% chitin. These hydroponic mushrooms operate self-sufficiently, relying solely on water for their growth, which eliminates the need for harmful fertilizers. Next, at our ultrasonic center, repurposed ultrasound technology takes control. High-intensity, low-frequency ultrasound waves are used to generate intense acoustic cavitation. This process, applied to the chitin extracted from the mushrooms, results in the breakdown of the polymer and initiates the deacetylation process. Crucially, this method eliminates the need for excess chemicals such as sodium hydroxide and hydrochloric acid, which averts the harm to the environment and mitigates the carbon footprint associated with the process. Following the ultrasound treatment, the chitosan proceeds to the finalization center. Here, vinegar derived from our lab-grown mushrooms is combined with chitosan, shaping the material into versatile forms such as plastic coverings, boxes, or bags. ChitoPlast sticks out in comparison to our competition because it is superior in every way. Our main competition and the most popular form of bio-based plastics is known as Bio-PET30. It is a part of the most popular form of bio-based plastics known as drop-in plastics. These plastics have many drawbacks, as even though they're made up of environmentally safe ingredients, they still manage to affect the environment negatively. They are not biodegradable, inefficient to produce on a large scale, and are highly expensive, costing over $1.50 per pound. ChitoPlast manages to outshine the competition by being biodegradable, efficient to produce on a large scale, and economically sustainable at only approximately costing 50 cents per pound. ChitoPlast not only minimizes environmental impact through its hydroponic mushroom cultivation and ultrasound-based manufacturing, but it also targets a broad audience. From environmentally conscious consumers seeking sustainable alternative to those who have been disappointed by previous bioplastic experiences, ChitoPlast aligns with the Blue Ocean strategy goals of reaching untapped markets and creating demand where it may not currently exist. ChitoPlast also introduces an innovative approach by using mushrooms, which is a readily available and renewable resource as a base for our bioplastics. This sets it apart from traditional petrochemical-based plastics and even other bioplastics on the market. ChitoPlast continues to aim to reduce the environmental concerns associated with plastic waste. We align ourselves with the Blue Ocean strategy's focus on creating products that are not only innovative but also environmentally friendly. The cost advantages with ChitoPlast also attract a wider range of consumers, including those who may have been deterred by the high price of current bioplastic options. Despite only being in the prototype stage, ChitoPlast has already demonstrated its potential. With more iteration, funding, and a full-fledged factory, we aim to refine ChitoPlast, making it suitable for various uses.